This is the first chapter in my abstract algebra series, chapter 1, sets. Number 1, how many elements are in the following sets? Well, if you look at A is the empty set, and the empty set has no elements, so the answer would be 0. If you look at part B, if you look at the brackets or the braces, notice there's only one element contained between the braces, and that's the empty set itself. So on part B, you would say the set contains one element, which is the empty set. Part C, if you look between the outer braces, you will see two elements in that set. One set is the empty set, and the second set is a set containing the empty set. So for part C, you would say this set contains two elements. Part D. Looking at part D, you see the outer braces, and then if you go inside the outer braces, you will see the empty set, and then you will see the set which contains the empty set and a set containing the empty set. So for part D, you would again have two elements, the empty set and then the set which contains the empty set and the set containing the empty set. Looking at number 2, specify the set of all non-zero integers using set builder notation. Well, if you want to include the set of all integers, you definitely have to be working with z, and x can be any integer in z except 0, and that's exactly what we would write. We would have set notation because it does ask for set builder notation, and we would say that x is an element of the integers z with the understanding that x is not equal to 0. That's concise enough so that most anyone should be able to understand that. Number 3, how many subsets does the set containing A have? If you want to know the number of subsets, the number of subsets is always going to be 2 raised to the power of n, where n is the number of elements in the set. This particular set only has one element, and 2 to the power of 1 is 2. We know we have 2 subsets, therefore, and those would be the empty set and the set itself. Remember, the empty set is always going to be a subset of any set. Number 4, what is the power set of the set containing A? Well, the power set of a set is the set of all subsets. So the power set of A is going to be the subset which contains the empty set and then the set itself. Okay. Look at number 5. Number 5, what is the power set of the given set? Well, we have 2 elements here, right? We have the empty set, that's the first element in the list. The second element is the set containing the empty set. Since we have 2 elements, we have 2 squared, which is 4. Therefore, there are 4 subsets. We have the empty set. We have the set containing the empty set. In other words, the set that contains our first element. Then we have a set that contains the set that's the empty set, which is the second element. And then finally, we have the entire set itself. The wording gets a little tricky when you get multiple brackets in there. Number 6, specify the set of integers that are both a multiple of 2 and a multiple of 3. Well, if a number is a multiple of both 2 and 3, then the number would have to be a multiple of 6. For example, let's let k equal 2m times 3n. Well, 2m is a multiple of 2, and 3n would be a multiple of 3. And if you multiply those, you get 6mn. And if you let mn just represent another integer, we could say that mn is equal to x. So let k equal 6x, and That would give us the set that contains every integer that is a multiple of both 2 and a multiple of 3. And that set would contain such items as -12, -6, 0, 6, 12, 18, 24, and so on. Number 7. Number 7 says list all the subsets of the set containing the elements A, B, and C. A proper subset is essentially the power set minus the set itself. We would start off, I typically start off by listing the empty set, which has no elements. That one is listed first. Let me just kind of highlight here. So here is the set containing no elements. And then I like to list the singleton sets, which are sets containing only one of the elements. So that would give us the set containing A, the set containing B, and the set containing C. So that takes care of all of the sets that have 0 or 1 element. And then I'm going to list all of the subsets that contain 2 elements. That gives me the set containing A and B, the set containing A and C, and finally the set containing B and C. Number 8, true or false. This is basically an exercise in understanding the symbolic notations. Part A says that A is an element of the set containing A. That's true. In fact, A is the only element in the set. Part B says that A is a subset of the set containing A. Well, that's false because only sets may be subsets, and A is not a set, it is an element. Part C, the set containing A is a subset of the set containing A and B. Well, that would be true because the set containing A happens to be one of our 2 singleton sets, the other singleton set being the set containing B. And part D, the set containing A is an element of the set containing A and B. That's false. The elements in the set are A and B. The set does not include an element that is a set. It is true that elements may be sets. In fact, we saw several of those earlier in this exercise. Number 9, specify the set that consists of all real numbers except for those between 2 and 3. In this case, I decided to include 2 and 3. So, actually, I did not. I excluded 2 and 3. So what we have here, using set builder notation, we're going to have the braces. And if you read, it says that X has to be an element of the real number system, and X has to be less than 2, or X has to be greater than 3. In other words, X cannot be any number between 2 and 3 inclusive. Number 10, describe this situation. Well, we have 1, 2, 3, 4 sets of braces. And if we work our way from the outside to the inside, and if we could think of any pair of braces as a box. So this would be, let's see, this would be a box on the outside here. And this would be a box on the outside here. For some reason my highlighter is not wanting to cooperate. Okay, so that's a box. That takes care of the first part. This is a box containing a box. Well, the second box would be the second set of braces. And then we have containing a box, which would take care of the third set. But notice that the last box actually contains 5, the number 5. So to read this would be to say, this is a box containing a box containing a box containing a box containing 5. Thank you.